Hi everyone, this is practice formative of chapter 4, question number 23. So in this question, we have to determine the number of ways 4 doctors and 4 nurses, altogether 8 of them, can be seated at the round table. So this is the round table questions. Let's recall all the formula that involved in the round table arrangement. That will be n minus 1 factorial or npn over n, or NPR over R. Always divide by the number of seats available, okay? NPN is arrange all, NPR is arrange some of them. Now over here, I think we have to arrange all of them. Therefore, NPR is not applicable here, only these 2. Now, when there is no conditions are imposed, 8 of them, so we just arrange, so 8 minus 1 factorial. Okay, that will be 7 factorial. Or if we were to use the formula NPN divided by n, that will be 8 factorial divided by 8. So if you expand the 8 factorial, it will become 8 times 7 factorial. When you divide by 8, you get back 7 factorial anyway. So let's just use the calculator. Okay, 7 factorial. The answer is 5,040. 5,040. Okay. If you prefer the illustration method, that means you sketch out in the diagram. So we have 8 seats here. 1, 2, 3, 4, 5, 6, 7, 8. Now the first person that take the seat has only one way of sitting, because whichever way that he choose, whichever seat that you choose, it seems to be the same for all, okay? Because the right side, the left side, the front are all empty chairs. Therefore, no difference, whichever seat that he choose. And once the first person has chosen the seat, so the rest will just go in accordingly. So we're left with 7 people. So 7 choices, 6, 5, 4, 3, 2, 1. So you can do this way. Okay, so that's part A. Now B, the 2 particular nurses should not sit side by side. If that 2 particular nurses should not sit side by side, we can use the complement method so that 2 particular nurses have to sit side by side first, okay? So the number of ways 2 particular nurses sit side by side first, side by side, okay? So over here, if I were to use the illustration method, so let's put them bundle up together. 1, 2, 3, 4, 5, 6, 7, 8. Let the nurse sit in. So there is one way to sit them, and among themselves, they will arrange each other. And once these 2 already taken their seat, okay, the first will go in. There is only one way to sit. So we left with the remaining 6 of the doctor and nurses. So they will take the space. 6 choices, 5, 4, 3, 2, 1. So externally and internally. So the number of ways for that 2 particular nurses sit side by side will be 6 factorial times with 2 factorial. So that will be, okay, we shall take 6 factorial and then times with 2 factorial. 2 lah. Okay. 1,440. This is when 2 of them have to sit together, but we don't want them to sit together. Therefore, the number of ways 2 particular, the complement way, yeah? Okay, the number of ways 2 particular nurses not sitting together, not sitting side by side, okay, that will be 5,040 minus 1,440. So the answer is, okay, let's get the calculator, or we calculate mentally. 5040, use the mental calculation. We get the answer also, 3,600. Okay, that's for B. Now, C, the doctors and the nurses sit in alternate position. So I will use the illustration way. So 1, 2, 3, 4, 5, 6, 7, 8. So let the either nurses or the doctors sit in first. Let 4 people sit in, since we have 4 of them each. Let the doctor sit in or the nurse sit in. So only one way to sit in. So the remaining of the doctor will be 3, 2, 1. And now there are spaces in between them, 1, 2, 3, 4. Therefore, the rest will take in their space. So 4, 3, 2, 1. Therefore, the number arrangement will be 4 factorial times with 3 factorial. 4 factorial times with 3 factorial. So 144 ways. Okay, that's it for question number 23.